My mic should be on now, and we're about to start the session. Okay, it started on its own. And I would like to make a special note to the people who are currently online. Ladies and gentlemen, I would not be able to monitor the chat, but please, I have a colleague with me who will monitor the chat. And if there are any remarks, any complaints, please shout out. Because usually I'll be presenting and my screen would be occupied with what I'm willing to share with you today. And this would be focused on 3 knowledge graph enrichment techniques, which would be dealing with reconciliation. This is aligning your private data to, let's say, gold copy master data. And basically here the preach thing is that we turn strings to things. This is the easy selling proposition. Then we'll be dealing with text analytics types, techniques and approaches, which are helping us get insights from unstructured content. The easy example that we can get here is news publications, again, as common source. And then the third part would be data which has a lot of velocity and volume to it. This would be like market data, which represents pricing updates. And the underlying data sets that we are going to use are going to be, this is the FIBO, the Financial Industry Business Ontology, the Global Legal Entity Identifiers, the LCC Wikidata, and like a NASDAQ top 100 companies, which would represent our, let's say this would be our CRM data, the key accounts that we care about. And since he's in the room, I would like especially to thank to Peter, who has key contributions to actually the first 3 data sets. And it's thanks to his work that I'm able now to showcase the 2. And if it's anything, it's Pete's fault too, not only the contribution. So what I would like to focus here, this is a special a value chain diagram, which I like quite a lot. This is courtesy of Mike Atkin. But this is the actual value chain. Why do we do all of this? What are we trying to add to our data in order to deliver all the capabilities, of course, the values at the end? The first and the foremost, we are trying to be precise and as much expressive with the identity. This is why when we discuss reconciliation, the IDs that we are going to discuss, all these strings, this would be of our primary concern, to identify each company in our case, what is the right ID. Then, we'll, of course, all the semantics is focused around meaning and the expressivity of being able to express your domain knowledge. But this, we rely exactly on the type of models that we are going to leverage. Currently, we're not going to be doing modeling stuff. This is perhaps, if you go, let's say, to Heather's workshop, she'll be concerned about this. And of course, the business rules and constraints are something that, I would leave out, but it will be important quality aspect. And this is why, we are going to be focusing on implementing, enabling the building blocks of what we our knowledge graph. And on this slide, I would briefly like to summarize the end goal. The end goal in this case is illustrated by an entity knowledge graph. We had a brief discussion with the gentleman why entity knowledge graph for a couple of reasons. First, entities, companies, organizations, or people are one of the key and most common data elements in basically all projects. This is the named nouns. This is the who moves the word. They are also, I believe in our assessment, they're present around in 80% of the use cases across industries. So whatever you do, I believe you deal with entities, or there is a great likelihood. And the second part is that they are easy to find, easy to find reference data. I'd say the GLAY data set is an excellent work with this regard, which represents foundational identifiers, global identifiers of legal entities. And what is our objective? Be operational, be it analytical use case, be it whatever we would like to do. each data system is data hungry. Like, there is not a single project in the world which would refuse some data in. And the knowledge graph works the same. So if we would like to know more, if we're able to deliver the analytical powers and the promise of the graph, we need to be able to add more and different data to the mix. So in this case, this slide, I have summarized the data point acquisition capabilities that we strive to enable in order to make interesting type of analytics. So in this case, this is the structured data. This is, let's say, in entities world, this is who it is, what are the company structure, what's the company classification, people associated, location associated, any kind of IDs. But this is, you can easily see and imagine why this is a structured data. You can easily imagine this kept in any database, which is fine. When it starts a little bit more graphy, when we talk models, when we talk like specific domain knowledge, be it the model of the actual thing that you stored, being some kind of external taxonomy or something which is imposed to you by a regulator, or internal classification, anything that you have to do for compliance or any other reason. This is the stuff which is in controlled vocabulary, glossary, ontology. This is the stuff that you enrich and you add meaning to this data. This is the promise of the semantic part, all these interchangeable models. And you know, like at this point, that if you combine this knowledge organization with your data, magic happens. But we would like, of course, to do more. And here, we would like to, I would like to add 3 aspects, because the good reference data is always the key. And let's say, yesterday I went to my bank's branch, and they knew stuff about me and the company which I represent, which was easily 5 years old. And they simply have not synced their whatever golden copy with what's the recent one. And our office was as a location that nobody is there already. My address was in a well-forgotten place. So like simply they relied on my data, and they have not synced to the golden source, even with the public information. And we are talking this type of issues which are every day. But to the greedy part, to these 2 mixes, which would be the pure semantical and like the structured data, the interesting part starts to happen when we start to add unstructured content. And of course, time series data. And if you imagine, let's say, this is the easy example from the signals from unstructured content. This is news corpora. It might be filings, reportings, any kind of narrative which is written down. We would like to be able to digest and get stuff out of it in the graph. And of course, not only get it, but associate it with the reference data and classify it under according knowledge organization. So it all needs to be aligned. It cannot be simply dumped in a warehouse-like manner. And the examples from unstructured content which I have chosen in this case, this is stuff which happens with companies, MMA events, road changes, some kind of legal enforcement actions. So this is stuff which makes in the news. This is why, like, for example, data set, it's easy to use the data set. And the transaction and pricing, this is the actual pricing data which I mentioned earlier. This is the volume and the velocity, which is totally inappropriate as a data structure to be indexed in a graph. This is the last thing that you advise to put in a graph. Something has a big volume and velocity, and the graph would put 4 indices on top of it, and it would be a literal mess. So this is something that you are very much willing to access, but you are very much not advised to put in the graph for pure data analytic structure. How this would tie together? Why you need all these components accessible by your big brain knowledge graph? A simple example might be impact assessment. Something happens, and you need to know as soon as possible what happened, of course, event classification, who does it affect, what is the actual impact. And let's say M&A or like enforcement action events are like the most popular one. Let's say I follow, for some reason, the Microsoft Activision Blizzard saga. I don't know if you're aware, Microsoft is trying to acquire this game developer, and it's back and forth. First, this was an M&A event, then it became a regulatory action event. They tried to board it, they were not successful, and there is always something going on. But what I need to know as a shareholder of Microsoft is what's the actual effect of the price? How does this affect the pricing? So I can answer like this type of questions of who, good, what, how much. And if we break down this into these foundational questions, who is involved, what happened, and what's the actual impact, we are starting to get fun questions that we're able to answer. But the components which we need to answer this type of information, they're hidden away for like not only in the public data. What we have found out is the most interesting information we have on site. Because let's say here we use GLAY, which is close to 2 million of entities right now. But I sincerely don't care about the 2 million of them. I care about a very small subset. Let's say these are my key accounts. And these are the accounts which I really need to know more about. So yeah, this is why in this workshop we have chosen reconciliation, text and virtualization. Let's move forward. Here I have a typical knowledge graph level application architecture, which I would rather skip, but this is the part which I would like to illustrate that you're getting your data from SQL, from CSVs, from any kind of linked repositories, either in structured or as documents in unstructured layer. You process it, and the idea is that you have quite a pipeline, sophisticated, that you're willing to put in the database, and of course expose via some kind of different interface. At this point, we're going to spend our attention on the integration layer mostly. And let's say the previous workshop, which was here, René from Essenza presented a very sophisticated, and I appreciate the complexity of the transformation pipeline. This is in this middle section. Let's say our friends and partners from MetaFacts, they are working on like the visualization side. So we are able to do this either by our tooling or by even appropriate commercial tooling. But for the purposes of a tutorial, let's do it like in a simplest way. So what we're going to show tomorrow, what is the intended workflow? Import a data set, which is custom. Let's say this is supposed to be our data. And here, I would like to make some clarifications. Nowadays, we work in a software as a service age. And the important thing, however, is in the typical constraint that we meet, given the rightfully paranoid nature of the financial institution, which has been no data should leave the premise. These would be the tools that you should be deployed in your data center. So I can do this without access to systems and data. So the purpose is to give the in-house developers tooling to enrich their own CRM data without using the power of what would be a SaaS service. And here we have to be a bit more manual given these constraints. But being able to answer, let's say, imagine this is my CRM data, a small subset of very secretive and important entities. Explore, clean them. This is not something which is but reconcile them to external identifiers. And why do I need the identifiers? I started with the value chain picture, but the IDs would be the key to for the enrichment for the data update. In my bank example, if they have reconciled our company with a master data set, they should have known their our current address, or at least they should have asked us, or should have asked me, is this your actual current address? Because we are in the absurd situation that if they decide to mail us, it would be a 5-year-old information, which is strange. Do some mapping, and this would be the reconciliation part. Import it to Taxonomy 2 and do some text analytics. Here, I would spend some time on exploring different types of text analytic approaches. And I'll start from what is standardly available, let's say on Hugging Face. I've chosen transformer from Hugging Face. I'll start to improve the transformer output. I'll try a couple of commercial toolings, and then perhaps suggest what would be even a better way forward. Because text analytics is such an open field and fast growing that I don't know if I'm able to surprise you, but the power of what I'm willing to suggest is the power of integration. Because again, we aim to be the knowledge graph which would gather all your data and your metadata, and not who will be able to give you the latest and greatest in text analytics. Extract the entities and events, and of course correlate the event with the price fluctuation. This is where the virtualization would come from. This is when you need to reach out in this external database and ask what's the impact of this event to these entities. So I mentioned that the identity and the identity resolution would be our main challenge, because this is the exact purpose of turning a thing to a string. And the ambiguity of the data set is the actual big challenge. Let me start showing you stuff which is not only a presentation. This would be this is the GraphDB workbench, which I would like to be able to run some queries to showcase the actual capability of the tool. And in this query, what I'm simply asking for is give me the number of subsidiaries of the companies which have the AO2 record in the GLADE dataset, and sort them by the number of the descending number of children. Nothing special, but what I would like to highlight here is that, let's say Morgan Stanley has almost 1,001. Let's say I would ask Pete now why JP Morgan has disappeared for some reasons out of this, but this is the information that we have in the latest data set. And you see that with this type of children, the ambiguity which is like possible is really, really high. And in the certain example that we see is that, let's say this would be a case, we see that each children, the same thing would be called in a different ways, like with different labels. This is one of the powers of the graph model, to be able to refer to the same thing by a different way. But what I wanted to give you perhaps yet another illustration of the ambiguity problem, which is one of the key problems when we're dealing with entity linking, which I refer to when I have to reconcile an entity from a text to an ID, or record linking, which is I have to match two structured data sets together. Please, these are my terms. I'm sure that you have like more precise one. So ambiguity, volume, inconsistency, and variability would be our challenges. And the typical better outcomes are achieved by reconciliation, anti-identification, which is based on like a scalable search, the types, which are of key importance to be able to recognize like apples with apples. Ranking, which is a feature of the graph, would help you suggest like it's a great feature for disambiguation. And of course, especially nowadays, you cannot go anywhere without a vector-based model. And what you see here in this discoverability, this is a totally speculative distribution of the different types of functionalities, how they contribute to being able to discover what's right for you. The traditional full text search contributes a lot. Then the right type and the rank of the data are also very helpful. And the vector embeddings are working on the really, really hard, last mile type of problems. If you're keen, later we'll discuss how these approaches, let's say a vector similarity approach, full text approach combined with ranking, work together. There is certain literature about, let's say, reciprocal rank fusion type of algorithms. If this is something which is of interest for you, I'm also having fun with this. But here the part is to be able to demonstrate the tooling which would enable this to do this on your data. And here again, your data is the key. Your identifiers, your private data set, your IDs in a private setting. And of course, here is the reconciliation, which the tool that we do is onto text refine, it turns strings to things. What does this tool do? Exploration, cleaning, transformation. reconciliation is going to like where I spent most of our time, and the visual mapping to a graph model, and then integration with the graph. So without further ado, I would like to start. This is the actual product interface of the Refine, where I would use data set, which is a NASDAQ data set. Which simply represents the strings of the top 100 NASDAQ companies. And it's simple as a string, which is the company name, and the ticker. The weight, the price, the current price, they're already outdated. So this is something that we can safely ignore. But let's imagine that this is the type of information which a sales representative have put into your CRM. And these are key accounts that you would like to tackle, address, whatever. This is your private data. And your objective is to be able to make it as rich as possible using the reference data, text analytics, and some virtualized data. So let's shape the problem like this. Do you have a comments on the problem statement here? Is this a good enough problem statement for you, even? Because usually the first thing that we should do is, of course, we would like to review it, we would like to facet it, and here I would be willing to let's say to do some transformation and to add a column on this column, which I'll call a pref label. What I would like to do, I would like to do something which would clean this corp inc corp type of non very informative suffixes. So easy thing that you would not be surprised that we support is the replacement and cleaning functionality, and this is not a very convenient way to type. I'll show you a cheat in a moment. So yeah, the basic, I would like to create a new column. On this column, I do a replacement, and I would limit myself with doing one transformation that just to show that it's possible. The good thing is that I have a local undo and redo functionality. So everything I do, I can replace. So this is automatable. But again, this is not what I'm after. What I would like to show you first how the magic works, and then to explain how it does, is let's say I would like to be able to issue a wiki identifiers, and this is wiki data identifiers. So I would like to use this column and enrich this column with wiki data information. And what I have here is a set of reconciliation endpoints, which are either publicly available or custom created on top of my graph. In this case, I use an internal wiki database reconciliation endpoint that we support. So it's because it's faster. And what we can do here is to use first the type. You recall perhaps this diagram, which is how do we reduce ambiguity, being able, of course, to do full text search, but we are determining the type. And this is the step where I'm able to state that what I have in my column is an organization, business, public company, enterprise company, which refer to the general wiki data type. And for sake of making errors, which I very much appreciate because they're much more informative that if I do this right, I would use the most generic type of organization. And I'll simply reconcile this column to the generic type of organization. So I'm able to hopefully observe some errors here. And here is an error actually. Texas Instruments, they claim to be Spectronic Instruments. Comcast Corp is X Corp for some reason. Netflix is right. Qualcomm. But yeah, what I have here the ability to do is to see what are the other possible matches and instruct it. That perhaps in this case, Texas Instruments, this would be the right way. And I don't know if you see good enough. There's a number which says what's the time score, but I can do this correction on my own. So like I have the right to, I have the ability to examine or choose new matches, or like even suggest an item here. And this is what it's getting me is, of course, you see that it's getting me links to the data sets. What's the benefit of it? It's clearly non-ambiguous. We know that it's Microsoft, and we know stuff about it. So one of the things which I might do is to get additional column which are getting data from the graph. And it would look something like this. Add column, okay. Add columns from the reconciled values. This is simply on the basis of the reconciled ID. It would reach out to the graph and will tell me what other information is available. This is the case with my bank. If they were treating me not only as a string, but as an ID, they would have been able to reach out to the reference data set and see, like, here are the alternatives way to refer to this. Here is the industry. Here is the preferred label that we might do. And to enrich the small column of data with all this additional information which would come from the reference graph, only because that we're able to reconcile and link it. This is how the actual linking works. And of course, we have to, I would rather review this in greater detail. But usually you appreciate the type of benefit which like an alternative label would bring. And if I'm willing to create fast text analytics graph, here is a fast and easy source for alternative labels, which is always beneficial for training and better assessment purposes. But like Wikidata has problems, and this is one of the things that we usually have to be really considerate of, that Wikidata is an encyclopedic data set. And it's not very careful with the legalistic meaning of what an entity means. So depending on your use case, the abilities to be able to select and to reconcile your custom data, either to something which is more precise from a legal perspective, or if for something which is precise from a general purpose perspective. What are the examples? What's the purpose of GLAI? The global legal identities, they have to be very strict in a legalistic sense, because the purpose, one of the driving purposes, is to be able to report exposure. That if you have bought Silicon Valley stocks or debt, example, when they ask you, like when the boss comes and asks you, what's your actual exposure to Silicon Valley, you need to be able to know who is this exact entity, all of its sub-entities, all the instruments that it's issued, so you know how much of them you have on the books. But if you are talking, let's say, Wikipedia stuff deals with general, like Mercedes. Mercedes is a nice brand. It is not precise to know that the legal entity, which is the parent company, is called Daimler Chrysler AG, which is listed in, let's say, it's Frankfurt, I believe. So it is very good to process information from the text, because they would talk Mercedes, but nobody would be able to, like, it's not referring to the legal entities. So this is why usually being able to combine and to create your own reconciliation endpoints is very helpful, because this is way how you'll be able to accustom your data strategy to your actual use case. And what I would like to continue showing is the exactly also the GLAI ID, which is, however, I would call this the GLAI UP, which is to stand for ultimate parents. And I'll explain in a second why I would like to call my column in this case, ultimate parents. Again, the situation that we're working, we have a huge reference data set. It has 2 million of records, and we have entities which are called very much the same. Microsoft, Microsoft Corporation, Microsoft US, Microsoft BV, Microsoft India, Microsoft Finance, Microsoft, Microsoft, Microsoft. Like in the corporate structure of Microsoft, everything is Microsoft. And when you refer that, I'm speculating here, Microsoft India has some kind of trouble. You need to be able to reconcile to the right entity, perhaps which is connected to the local market, but also to attribute this to the actual parent company. So this is where the reference data and the graph would be very helpful, because the reference data would give you the structure, it would give you the precise legal name, and it would give you what's not in the text. This would be the impact analysis. Another popular example these days is Elon, who like pledges Tesla shares, and then he does something which is not extremely wise with another investment of his. The impact analysis of the co-owner of these two entities goes via the note of their owner. However, this information can only come from a structured source, and the best structure to hold this is the graph, because this is why I know, like, if the Twitter price comes down or the whatever, then perhaps the shares the Tesla shares which are pledged, they are going to have some co-options executed against them, and this would directly influence their price. And this type of inferences, this type of relationship and connections, they exactly require this type of capabilities to integrate structured data, knowledge organization data, transaction data, and text analysis data, if you would like to be able to deliver this type of analysis. And the part of it would come from the text, the part of it would come from the graph. And this is how, like, the other promise that we might inevitably go, how we work with GPT would materialize, because GPT knows only what's in the attention window. But here I would like to demonstrate, let's say, different type of reconciliation strategies. Here I have created only against GLE, I have created 3 endpoints. Since this is my indices, I can create as much as I want. But the first part is like a special index which contains only the ultimate parents, which means that for Microsoft, I would like to search only for the parent company which is listed on the exchange. I don't want to know anything about the 100 companies which are below. Why? Because I exactly would like to avoid the ambiguity of Microsoft Corporation, Microsoft NV. This is first. The second part, and I expect when with the ultimate parents, I expect high precision. I hope that you have this, the type 1, type 2 errors, but I expect whatever I tag to be the right one. I'm happy to miss stuff. The second approach is the O entities, which I expect a high recall. I expect a lot of errors, but everything should be tagged. And then the third strategy, this is the common name strategy, which proves to be very helpful, but from data science perspective, this is introduce a separate chaos. But I have done it, and it represents that all parent companies are tagged as their, all subsidiaries are tagged as their parent company, which is a total data mess, but it's very helpful in many cases. In the newspaper cases, when I talk that Google, her parent Alphabet, does something, the impact is on the parent company, but Alphabet is never mentioned of their structure. And this is why, like, it's a really messy approach, but I'm willing almost to brag that I'm able to do stupid things like this, because I control the graph, I control the reconciliation, I can do basically whatever I want. Or the use case, which is for the third, is like it's the best approach of when you're reaching CRM data. Imagine the following scenario. Somebody goes in a form of your website, he fills his name, his email address, and the company he works for. This is the Hail Mary scenario. Because he'll say, I work for Goldman. Which of the 1,000 Goldman companies? I work for the Mercedes. Which one? Like, he doesn't know. It's very likely that he doesn't know himself. You do not care, because you need to work with the parent company. And this, where the legalistic form is not that important, this is perhaps a good reconciliation endpoint. So how does this work in practice? Let's have some fun with this column. And what I would like to do is to start reconciliation against this ultimate parents endpoint. And I'll be like, again, I need some errors. So I'm doing the fasting first. And it's, let's say in the Microsoft example, it correctly resolved to the Microsoft Corporation, which is tagged as ultimate owner, so it's fine. Apple looks, this is usually, we got this right. The top NASDAQ companies, we got them right. The interesting part starts a little bit down there. Let's say Texas Capital is not Texas Instrument. We don't know what this is. But the right way to do it is, let's say, to compare it. So I'll add another column. And I'll simply reconcile this column to, let's say, to the GLAY endpoint. What is the purpose? The purpose is to be able to do side-by-side error analysis. At least my thinking is that I am mostly interested in the errors themselves and not when we got something right, because the errors are usually much more informative how the technology works. So what I would like to point to your attention, and this is something which I can spend a lot of time, is how the ultimate parent reconciliation strategy worked, how the reconciliation against all entities work, and how Wikidata presented. This green bar here tells me that with the ultimate parents, the reconciliation was able to reconcile, let's say, 94%. And there are 7% which are yet. With the all company strategy, it claims 100%, which is not the case. And with Wikidata, it was able to reconcile 99%. And bear in mind, this is like the top 100 companies in the world, so it's not something to be proud of. It is not really the hard cases. However, you would be able to see like that there are actual errors. In the ultimate parents case, I was able to reconcile this to the Microsoft Corporation, which I know to be the true parent. But with when I run this against all of the entities which are in the GLAIF data set, the reconciliation stated that this is the Dutch entity, or that's actually the Belgian entity, which was suggested as the purest match. And this shows exactly the precision versus recall balance, which we're able to control and to play by creating a custom endpoints. Like here, it reconciles the right ones, hopefully doesn't do much errors. Here, it is likely that it's going to be a very high recall, but it would do better. What is the right thing for your use case? I have no idea. Like this is a tool that you should be able to use on your own and make the right type of judgment. In this case, like I'm able to go manually and say, okay, this is not the right Microsoft, but this is the right Microsoft. So I'm able to do corrections if the interface allows me. Eventually. But the point is to give you the power to use your data in one more way. Please.
So are you looking at string similarities and finding possible matches?
Not in this interface. Actually, this is string similarity, yes. This is exactly what it's done. Because the way that it's done, it is done on top of an elastic endpoint. And the way these elastic endpoints are created is by getting your data from the graph and indexing it into like an elastic endpoint. And here's where I'm going to go next. This is power from the product, is I'm able to get a subset of the graph, a graph pattern, and index it in an elastic and use all the string similarity and indexing functions which are possible with the addition of rank and type data. This is why it's not simple similarity. It's a little bit fancier. And this is like my next thing, which I'm going to show you, how I create one of these endpoints. And it would be something, first I would start with creating like a query like this, which is give me a GLAY general entity, get me the legal name of it, so at least one string, and please make sure that it's an ultimate parent. How do I determine it's an ultimate parent? I have done a shortcut on top of the model, which helps me get the easy pattern. and then a set of optional queries, which are asking for if there are alternative label, previous name. Let's say previous name is very helpful when we talk about Facebook and Meta platforms, because nobody calls them Meta, but the actual legal name is this. Any kind of base name or anything which this gentleman has put into the ontology, which he recently updated, and I'm totally unprepared with the new ontology. But yeah, I'm able to improve it constantly. So this is like exactly what it shows, like this type of pattern. I'm able to unwind this into an elastic. And what this gives me is the ability to synchronize the graph data with an elastic index. And what is the connector? It keeps the data alive. So if there is an update on the graph, then it's updated also on elastic. And here, of course, I need the immutable structure because I need fast searches. So this is how I'm able to choose the sub-pattern of the graph to accommodate my reconciliation strategies. Because ultimately what I would do is like for the ultimate parent endpoint, I would put this requirement. I'll have this clause. If I would like to run it against the old companies, I'll remove it. Of course, I'll be able to also play with the type to include the funds, the partnership, and this type of stuff. But this is my data, so I'm able to issue it, like to do whatever I want with it. And this is the power of creating your own custom reconciliation endpoints.
Yeah. So during the reconciliation, right, we are matching one entity, but rather than matching the strings of it, are you trying to tell that we'll also match the connectedness of that entity? Maybe it is connected to a place where you take that also into consideration to match it.
Exactly, because this is the stuff which I'll pull from the graph. Further, the ability is to this is something which is not very well demonstrated here. But if in an example case, like when in my reference data, like in my CRM data, I would have a location, zip code or whatever, the search query would hit two indices. In my Elastic would have the zip code or let's say the state, and it would able to figure out that when I'm trying to reconcile the CA code, it would know that it's a California, the state, and not Canada, the country. That there is a country which is called Georgia and a state Georgia. There is this is a very much stuff which would be able to combine what's the knowledge in the graph with the actual realities of your data. And this would only lead, the actual lead is to improve the overall quality of the matches. But the point is, yeah, use as much knowledge from the graph as possible in order to achieve better reconciliation or better IDs or precise IDs. And here the focus is not that much on the actual software, but it's a data quality focus. Our focus should be the quality of the data. This is basically what I wanted to show you regarding the reconciliation. The ability to do your own reconciliation endpoints, to import and reconcile using different types of strategy, and to compare and to evaluate what works best for your use case. To be able to mix and match, because when this works, I'm able to do types of mapping that, let's say, this Wikidata ID is the same as this GLAY ID. Or it's I would use something more loose semantically, because I told you that these are different types of data sets. And when I'm done with this, I would like to, I am usually going to do an RDF mapping, which is I'm going to cheat on this, and I'm not going to do RDF mapping on you, and I'll show you already one. But the point is I have combed my data, and now I'm willing to put it into a text analytics tool. So I have reconciled it, and I'm willing to import it into a text analytics tool. And in this particular project, I have done the mapping, and I'll show you a visual RDF mapping tool, which this tool supports. And what does it do? It takes all the columns and it somehow organizes them in a graph model, which you recognize here. It's somehow easy. You have a company name, alt label, Wikidata ID. These are the columns from our original data. And they're organized in something which, if you've written enough RDF, you recognize it's an RDF pattern. And in this case, I have chosen the Wikidata IDs as my lead ID. I tell that this concept, I using the Graphite too, so I have to explain that this concept. Then I say like, okay, here is the prefer label, which would come from the pref label column, which I created with the cleaning. Get me some additional labels, and this is the thing which I was not able to do a demonstration. This is how I convert this into the scheme of the Graphite tool. So my objective is to easily like download this as a JSON, RDF, or open directly into GraphDB and upload it in my taxonomical tool, which would help me do the text analytics. And to save some time, here is the actual taxonomical tool. So you see how it looks like when I import my, let's say, NASDAQ entities in this case, into a taxonomical schema. And here is my company schema, which contains all this information. And let's say for the Activision, it has all the labels, but it also has the, these are the GLAY identifiers, and it also has the Wikidata identifiers. So it's no longer simply labels, but it's something which is connected. And the point, this acts as first a taxonomy editor, schema editor, but also as something which will power the text analytics part. And I would like to point your attention that to this project, which is the KGC demo project, I have added 2 additional schemas, which contains the FIBO class and the FIBO properties. These are taken from the FIBO ontology. What do I use it for? I use it for like this type of event detection, because some of the stuff which can happen, let's say the corporate action, they're included in the FIBO ontology. And I'm taking the SCORS version of the FIBO ontology in order to be able to recognize and identify these events. So don't forget, the overall objective is to identify the entities, and FIBO helps me to identify what happens with these entities, how they're interrelated. Let's say that this is a simple vocabulary which I'm using to utilize in order to be able to do a better demonstration. So we are starting to move towards the text analytics part, where I would like to like, again, highlight the importance of the identifiers. And mostly what I'm going to do is to start reusing different types of text analytics capabilities in order to extract stuff from unstructured content. But I'll rather pause for question and related the reconciliation part before we move into text analytics. Any comments, questions? Milen, do you watch the chat?
Yes, I watch. No further questions.
Good. So this is where we are going to be spending most of our time. What are you looking here? This is the metadata studio. Again, when we're dealing with unstructured text, we need to be dealing with metadata. And one of the purposes of this tooling is to turn something which is traditionally thought of as a software task, text analytics, into a data-centric task, which is, again, our primary concern should not be how this extraction is done, but does it work best for our use case? And this assessment is usually based on a text, like on the statistical type of scenarios to see how it matches with our requirements and what type of tool does whatever we need to do. And in order to do this, we need usually text corpora. So here I have created like a project. In this project, I have a text corpora. And let's, within this project, let me put some kind of, again, I have selected something which is, again, related to the document which is related to this Microsoft Blizzard recent events. And I'm going to put some title. Really most convenient. And what we would like to do here is to be able, like this, this can be, of course, as long as we need, but we need to know, to understand what we are able to make out of this text. And here I'm trying to introduce like a gradation, or like, let's say, the levels of sophistication that we can, the tooling that we can do in order to extract stuff out of it. And in my opinion, being able to go to Hugging Face and download a model is like what anyone would be able to do. Like, let's say this would be done like in here in a visual, VS Code. This would be like the type amount of code which I'm able to process this text and extract some tokens, which is relatively naive. Nowadays, something like the Codex or the GPT would do this easily for me. But I would like to incorporate this. And the power of this tool is that we are able to call different annotation services. And here is the key type of functionality where I would like to show with you that I can register here a service which is based on this BERT model, particular version of BERT. I'm willing to call this to call this model to annotate this corpora, and it produces an error. Very good. Have no idea what the error is. I don't plan to investigate right now. But still. No idea what the error is. Okay. Let me see. Like, here is okay. Let me just use a pre-example when I was able to do this previously. Here, I'm able to when I run the BERT model. Of course, in the tool, I'm able to filter by creator of the actual annotation. I see that when I run BERT, it recognizes two organizations, which in this case are Microsoft and Google. In this snippet, which produces this type of annotation. The second level, which I wanted to run on top of BERT and which would be unfortunately failed for some reason, is when I combined the type of strings which BERT would produce, which are ultimately strings which are classified as organization. I would like to combine this with the reconciliation service. So I basically take the strings either from a column or in this case from a text. And I send the string to like a reconciliation endpoint. So it is able to give me, well, not only like who is this, but what's the type. And in this case, I very much am able to do this in reconcile. Come on, this is not satisfactory. This is the BERT thing, which is freely available. I'm able to combine the BERT with reconciliation. So I have my classified strings. I have a reconciliation candidate. The other thing which we might do conveniently here is to add, let's say, a commercially available service. And in this case, let's say Google is my go-to example because they are the big brain, and hopefully this would work. To annotate the corpus. But what is the logic? What is freely available? What's available for money? And what you can do if you like to do some custom stuff. I don't like the look of it. Oh, it's completed. Okay. So here I'll have to, yeah, Google. Okay, so Google expectedly was able to extract this company. Blizzard is a company. Tencent and Sony are also. And this is stuff which I'm able to further reconcile to Wikidata. And here there is a magic trick that we do. And if you have used the Google NLP, you would know that it actually issues Wikipedia identifiers. Which is, and in this case, I'm issuing Wikidata identifiers. This is a magic which we have done in the background because our reconciliation strategy was based on Wikidata. And as a part of a research project, we have done mapping between Wikipedia and Wikidata. So now we are able to use exactly the semantics in order to match when somebody speaks Wikipedia language. So it issues Wikidata IDs. if we run this into the Google's own demo services, we see that there's a Wikipedia links, which is yet another thing that we might use the graph for to translate ID from one ID to the other. And of course, the other annotation service which I would like to present is the tagger, which is based on our taxonomy editor. And the Google example is really good because I expect it to err. I expect the custom tagger that we built, I expect it to produce errors. And the errors which I expect it to produce would be exactly the errors which any standard tool would produce. It would not know that what is Google is actually Alphabet. And in the NASDAQ's dataset, it was Alphabet. So let's, when I go to the document and filter the annotations by creator, and I would like to move Google out. And actually, this is not the document which I'm looking for. Microsoft would be recognized, but Google would not be. And here, like I would like to make an error on purpose to illustrate the following concept, that in this tooling, like what I need to do, of course, is to come here, say like Alphabet, like a search for Alphabet, and it would tell me that, okay, here is the record for Alphabet, which the course record for Alphabet would appear. Why it would appear as Alphabet? Because it was my reference data set. But what I need to do, and it would be properly associated with the GLAY IDs, and you would understand that what everything I need to do is to add as an alternative label, let's say Google, save the properties, and do a quick rule-based correction. So what, again, am I doing? I'm doing something really ugly with this form. I'm using the richness of the alternative labels in order to be able to do a better string matching. But the purpose of this is that I need a platform which allows me to do the manual rule-based annotations and combine them with the big like machine learning type of approach, let's say the BERTs or the Google services. And the combination of these two approaches would allow me the flexibility and the reusable power of two approaches. So let's say the typical use case is as follows. Nowadays, we would like everything to be machine learning. So we would like everything to be in our model. However, like specifically in the news domain, new prominent concepts are coming every day. Like I have not, fortunately, read the news these days, but there would be some key events which would likely dominate the field. Let's say, if you follow the GPT, auto GPT is a thing, or it was a thing. LangChain, this week's old now. But let's say LangChain appears as a new concept. So you would like in your text analytics, you would like to find LangChain stuff. You cannot afford yourself to retrain your model in an hour. It would take a while. But what you can do is to simply go and do a string-based similarity. And of course, do the retraining on batches. And this is what I wanted to demonstrate here, that when you have the availability over one corpus to utilize different services, some of them would be based on stock models, some of them would be custom, some of them will be very manual like they're here. The different types of techniques would lead us to the same objective of being able to extract as much data as fast as possible. Because the ultimate objective here is to have high quality data in our graph and not to miss stuff until the right technical way is implemented. So here, if I go and do the same, let's say annotate the corpus with what is here, the explainability tagger. I very much hope that it would, when I go and say like the news about the Microsoft and Google, Yeah, Google is already recognized. Here is the annotation that this is actually the alphabet entity, which has this certain ID, but now it's recognized under the label of Google. It's very simple, it's very ugly, but the important thing is the combination of the different types of techniques and approaches. I am not going to surprise you with yet another example. The point is to be able to utilize all the different techniques for the purpose of getting the best type of different types of data in your graph. Since like the BERT integration was not able to accomplish, I would simply summarize most of the point is, again, the importance of identifiers of text analysis humongous. Nowadays, if you talk text analysis, you are talking transformers. Transformers are not very good for this purpose. The disambiguation task is still to be improved specifically, especially if you're dealing with disambiguation of hundreds of very similarly sound entities without sufficient context in the text. This is a very hard problem. So this is a specific case where the graph is extremely helpful with all the links and context it can provide. And it's not that it's a magic bullet. It is something which gives you the additional features in the additional context that perhaps would, and the right combination that you'll be able to figure out for your certain use case. Because when we get into the use case specifics, usually we find out that it's not the killer capability which matters. It is to be able to fine tune to the specifics of your use case. Let's say an easy example is if we are doing medical type of coding and extraction, this is where precision is everything, because we are not able to mix chemical substances and say like what is one substance is the other. This should not happen. But if we're dealing with recommendation, high recall is totally fine. Like somebody would learn something new. And these are the two easy extremes when your use case determines the type of risk and the type of techniques that you're willing to take. And the underlying promise which we are willing to take is that this is no longer that much of a software task, but this is a data quality problem. Usually when they come to us, they have a data quality problem because what's our objective is to provide data to make some decisions. And they would like to know that when they stand before whatever the analytics engine spew at them, it's the good quality data that they're making their decisions on. So this is why I'm underlining the diversity of the techniques which are available and not willing to impress you with the latest and greatest in this field. And with the text analytics part, I would say that this was a very initial illustration of how we are able to get data out of unstructured text. So with this regard, I've tried to do reconciliation with structured data, unstructured text, and the last part would be getting some kind of transactional data. Please. What have I done? So a good moment to pause and ask questions. The text analytics is an endless topic. Yeah, it indeed is.
You say that for this task, models like transformers are less good. Did you try embeddings that are based not just word embedding, also character embedding like Elmo or fasttext?
I have personally not done these. Like I know that after the transformer craze started, our teammates have done a lot of experiments, but if I have to explain what we have tried and what were the reasonings now, no. But currently, what I can state that if you convince me otherwise, that disambiguation between substantial amount of candidates which are not expressed in their full legal form in the text themselves is still a very open problem.
Yeah, sure. Yes, sure, but
lie to me, please. I would be very happy to be wrong at this stage and take all the blame. But this is the ambiguity of the actual word is tremendous. Okay, sorry, we're struggling with this. And this is why, we would do all kinds of tricks, but it's a hard problem. yeah, simple like stuff, which is, we are on a Roosevelt Island. There is a Roosevelt Island on the Potomac River in Washington. And there is Roosevelt bridges. And there is the actual Roosevelt. Being able to disambiguate between them, which the transformer decently works, like what class is it? Good, but when we, let's say, when I was in New England, I take a trip from Hanover to Lebanon by the bus. No way. This doesn't work. A text analytics thing which genuinely ghosted. Sorry?
Yeah. So transformers works on like understandably the open data, right? What about we have our own graph where we build our own context, right? From there, like then disambiguating with the context that I have.
This is where the fun starts. This is when the fun starts. Like this is the promise of being, like here is the promise of the graph is a bit different. Let's say the conservative promise of the graph, because I trust it can do a little bit more, but it's usually high quality data for your AI, for your machine learning. This is where all these additional features, let's say in the disambiguation, what's the type, what's the rank, these are yet another features to your model. And you're able to train with, this is the better, like less garbage in, less garbage out. No more sophisticated than this. And this is what we see that, let's say the data scientists, the AI experts, however they want to call themselves, they are prime users of the graph because they have convenient access to a lot of high quality data. Because from a data science perspective, if you're able to get all these features in their heads, like at a one endpoint, which is the graph, they forget about it all. Like this is like this is the actual demand that we see. Is like somebody who wants to get a high quality data, which is integrated for him, so he can fly like a bird and do all the machine learning magic, because this is all monstrous amount of features for him that he doesn't have to clean, that doesn't have to type it. It's ready. So this is the, like in this conservative model, when you would like to train your own thingy, this is the promise, which is usually very well received. And I don't want to go one step further and told you graph analytics and magic on top of it, because we'll get into philosophical discussion. Would you like to be able to implement your latest paper that you freed? Or you would like to do something which is as a graph product? And we can spend some time on it. But this is a more a political decision. If something which should be very much predictable and deterministic should go into the probabilistic territory of like any kind of model which deals with probabilistics. You rely on a database to return consistent answers and not to improvise, and you'd like to be able to take the risk and do the statistics yourselves. We're getting into philosophical stuff, but these are like design decisions in architecture, what type of system you trust for what, which are somehow they should be conceptually clear and important.
I guess like with the companies you work with, like how much of their data that's where they run this like reconciliation like test, like how much of it is like manually checked by like data stewards to check for accuracy?
The promise of the reconciliation, I very much would like to be very conservative here. The previous workshop here was addressing the larger problem. Like reconciliation, in my view, this is like, let's say, work with personal definition, is when you have a subset and you're willing to link it to the superset. This is like a partial problem. The previous workshop was addressing the more general type of problem, which is the record linking, which is like two sets which are like partially overlapping. So reconciliation is a utility. It's not meant to give you like the higher quality. It would something which would fit into the data stewards process. And all this replicability, everything that is recorded, everything that the choice that you make or the suggestion would improve the quality, but it's more of a time saver. It doesn't save you the proper data governance task. It would be like a do the easy things fast. So let's be clear, like I don't want to do data governance, replace data governance. This is like easy things fast type of promise. And if I can get 60% of your data right, fine with me. Does this answer your question to extent?
Yeah, I might extend the question to include also like the ID recognition stuff, like the new stuff. Is that intended to be not as, or is it intended to be at the same level of accuracy as like the
Usually, here is the use case in this is a bit different. Let's say public customers are the BBC and the FT. The nature of the news publishing is such that something happens, and then all of a sudden, most of your content is about it. So the crucial ability is to be able, whatever thing happens, a new concept appears, you need to be able to start recognizing and you classifying your content. Because all of a sudden, you start producing content about it. Something happens, people start trading, people start talking about, and speed is of crucial importance. The need for time to retrain even the any kind of machine learning model, which would recognize something which is in the like volume of millions. Let's say a company data sets creates volume of millions, is prohibitive. This is where the ugly hacks work. Because when something new appears, let's say Twitter becomes the X company, improvising. You start writing about the X company. You need to know what the hell this is. This entity which just emerged. And you have decisions which are bet on this entity and interrelate. There is no way that you'll be able to retrain the model in the time that it's like the news are out. This is where you need the techniques. And I'm not telling you that for every case you need this technique. For example, in the sciences, like life sciences, material sciences, you don't find a chemical element every year. You're safe to train your models on whatever the current table is, and you know that it would last for a while. But not in the world of the news and not in the fast pace for the finance. So being able to have a rich tool set perhaps is the value proposition here, not the right way to do it. Let's continue the discussion. I feel that you have.
I was just hoping you had like a number like 10% of the license.
I'll lie to you. Whatever I like. Let's say this is from like an actual practice. Like it's actually the stories which we have. Like when the artist known as Prince died, we were visiting Bloomberg's offices. And these guys are starting, the Bloomberg media was starting to produce news on Prince. And Prince is a hellishly ambiguous word. It's like the artist known as Prince. In UK, there are a bunch of princes. The Japan royal family has the princes. There were actually armed forces which are called Prince. But you start producing news about it. And you need to know what this news is about. Another unfortunate event. Again, I was in the New York newspaper, like the New York Times. At the moment when this a while ago, there was a shooting in France, in Paris. There was a shooting in a place which was called Bataclan. And all of a sudden, these guys started to produce content about Bataclan. And you need to be able, and the New York Times is very good with this regard. There are a couple of Twitter accounts which are showing what's the new word in the index of the New York Times. There is a new word there. Because they publish their reverse index books at the end of each year. When you find the topic and you see it's the newspaper of record when they wrote about it. But the fact of the matter is that something happens, a new entity, like a new concept, new topic. This is topic detection actually. Appears you need to be able to write about it. And if you're this is in the newspaper, I don't think that if you have any sympathy for the newspapers, you would have some sympathy. No, you should perhaps less sympathy for the traders. When there is a change in the market and an event is mentioned in the paper, and they need to start trading and make sense out of it. What's the impact? What happens? a war starts, what's the actual impact? Let's say there's elections in Turkey. So not advocating, understand your use case, understand your requirements, and then we figure out what's the right thing. It might, I don't know what you actually do, so it might be totally non-applicable for your domain. I'm starting to, my appeal is with the diversity of techniques. Good. The last thing which I wanted to show is getting relational data. Let me do the fast stuff here. I would speed it up a bit. We were dealing with NASDAQ companies. Like at this stand, I would not log in into any kind, but you have seen a MySQL database. What it does do is like this is a trading data. This is the type of data that we discussed that you would not put in the graph or not, you should not do, because these are updated. Like this, in this case, it's end of day trading data, which you can put in the graph. But for the sake of example, this is something which is updated every few milliseconds. And this is something that you would rather not. Which symbol, on which date, like what was the actual pricing. Where we would like to measure the impact of the event, this would be who, the entity detection, the reconciliation, the event detection is what happened, and this would give us the monetary impact. And this is the last piece of our puzzle, that we need to be able to reach this type of resource, which is not stored in the graph. What's the data integration pattern? It's called virtualization. But this is like the ability when you have a high volume and velocity data, then you don't store it locally, you reach out to it. And I would rather share this slides with you, because I'm now speeding up in the interest of time, that you like have a physical model of your data. There are kind of heterogeneous sources, and the graph acts as a single point of access. And get a hold of the data, prototype, or like this is simply cannot be copied. Like in the pricing data, it is something that you would rather not copy. In the security consideration, that you would not be allowed to copy, but still somehow reach it. And the case is again, forecast stock market price. This is a bit generous on the forecasting part, but again, a data scientist usually appreciates if he has all the historical patterns when what was the actual impact when event like this happened. Let's say somebody office, like a prosecutor enters an office of a company. A letter, consent order is issued. They reach a settlement. What's the impact? It's the dream data set of a data science to have this historical data, so he can speculate last time that it happened, the impact of the price was this and this. What if this event happens? So this is helpful for risk analytics. This is helpful for any kind of trading strategy. Basically, everybody who has some kind of trading company has a logic like this. And it's not something novel. Here, what I'm accenting is the ability to integrate this together. And again, speeding up, I would show you the details. But the point here is that in the technology, we're able to create these virtualized connectors. And the interesting part is that, of course, we figure out the connections, but we have our own ontology, which is able to explain what this data is. And I find it a very educational perspective, that when we deal with table data and we put an ontology on top of it, it is usually for the introductory type of course. It's much easier for them to understand that this column, which was from the previous example, like this is how a relational table would look like. When you put an ontological model on top of it, it is a very easy way, or at least it works for me, to translate the value of the semantic model, because they're able to say, like, we have this now, and when we put, let's say, specific that it's that this is something which is securitized flotation, that it's on a specific market which has its own ID, on that it's actually deals with a trading day, which has a proper label and definition, it's a ticker and this type of stuff. people like who have dealt with data and suffered the consequence of data life, they start to click and understand what is nowadays called a semantic layer. This is stuff which is actually helpful. But in this case, I'm able to put the data on top of the model in order to explain it. And of course, I have also a mapping file, which in this case is created via this text-based syntax. If you're interested, like there are commercial partners which offer visual tools in order to be able to speed up this creation of virtualized mappings. But the point is to be able to integrate a source which is not physically present, and to present an endpoint. And what would be a good example here is, let's say, a chartable NASDAQ. I go to the repository here, which is a NASDAQ. This is the NASDAQ repository, which resides in a MySQL table, which I showed you, I connected and I explained what it is. When I run a query against it, it returns something which is time series. And in my use case, I just simply, for the sake of it, I would like to put a chart. And the chart is, in this case, I am able to get all these columns from the relational data set, but I would like to sort them by the difference between a closing and open price to see where the actual impact was. Why I choose to make this analytics? Because for the event detection and impact assessment reasons, I am very curious to do association between what happened, what the paper is written about, and what was the actual effect on the price. And this way, if I look at it again from text analytics purpose, and I'm able to somehow correlate, would be a generous word, but stock fluctuations and events. With who these events. And the fun only starts when you have to have this data together. And I believe that, yeah, we are at the time now. And that what I wanted to show is we use reconciliation for who, text analysis for what, and virtualization for how much, in order to be able to build a graph which would be able to answer quite an interesting question. Let me stop here and have some fun with a discussion, perhaps. I rushed this a bit, I'll be happy to provide more details, but I kind of like it, so I speak a lot fondly of it. Yeah, actually, the virtualization part is freely available. You don't have. The product is called GraphDB. There is a free version, so yeah, you can go and play with it. You don't this is the. The answer is yes. Come on, Milen, anybody online?
Tricky question. Are you suggesting that data governance is not needed?
No.
So just for fun. No further questions.
No, come on. Data governance has its totally different objectives and totally different workflows. Good. Then I should thank you. And if you have less of a kind of a suggestions or comments, I'm still here to take them. Thank you all.